All right, everyone, welcome to 4-4 Solving Proportions. In this lesson, our objectives are I will be able to find the answer to an equation using proportions and explain why we use reciprocals. This might be a new word for you. We're going to talk about it a lot today, but most of these you got in your concept lesson. So remember, a ratio means we're going to compare two amounts. And a proportion means that two ratios are equal. Okay? This is what we looked at with our concept earlier. So let's start with building background. It says Mr. Sayers has a ratio of 3 golf shirts to every 2 pairs of golf shorts. If he has 16 shorts, how many shirts does he have? So I'm going to first set up my table. I know that I have shirts and shorts. Okay, he has 3 shirts for every 2 shorts. And then I know that he has 16 pairs of shorts. So I have to get shorts to 16, counting by 2s. So that would be 2, 4, 6, 8, 10, 12, 14, 16. Now I'm going to use the same amount of times to count by 3s for shirts. So I have 3, 6, 9, 12, 15, 18, 21, 24. And my question asks, how many shirts does he have? So my answer would be 24 golf shirts. Okay, so let's look at some examples for how we would do this using two ratios. So we're going to solve x over 10 equals 9 over 6. First, I'm going to write my problem. And then I want to think through. This should look pretty familiar to you with finding this variable for x. So I'm going to undo this divided by 10 by multiplying both sides by 10. So I'm going to multiply by 10, and over here I'm going to multiply by 10. Okay, now remember, when I have this dividing, I have to do this first before I can multiply anything by it. So over here, I've gotten rid of my 10, so all I have is x. And before I can start multiplying that by 10, I have to divide. So I'm going to first take 9 divided by 6, and I get 1.5, and then I'm going to multiply by 10. And my answer is 15. So what I did was I took 9 divided by 6, and that gave me 1.5, and then I took 1.5 times 10, and I got 15. Okay, so that means x equals 15. Let's try another one, number 2. I have 10 eighths is equal to n over 10. So I want to find out n, which means I have to undo this divided by 10. So to undo divided by 10, I'm going to multiply by 10. Okay, so I'm going to draw my line down here. I'm going to multiply this by 10 and multiply this by 10. Over here I have n, and I have to figure out what this is. Before I can multiply, though, I have to divide. So I'm going to take 10 divided by 8. That gives me 1 25 hundredths, and then I'm going to multiply that by 10. And that gives me 12.5. So n equals 12.5. All right, turn your paper over. Now I want you to notice that this one looks a little bit different. On the last two that we did, our variable was in the numerator spot. That's where it needs to be for us to solve these problems. So notice here, our variable is in the denominator spot. So we're going to use reciprocals. Which means we're going to change our variable And we're going to also change the next side. We have to change both. Remember, what we do to one side, we have to do the other. So we're going to change our numerators and our denominators. Okay, so if I had 4/3, instead I'm going to write it as 3/4. And if I had 8 over x, instead I'm going to write it as x over 8. Okay, then again I'm going to do my same steps. So to undo divided by 8, I'm going to multiply by 8. So that means I would multiply by 8 over here and also over here. So my first step is going to be 3 divided by 4. And I get 0 and 75/100. And then I'm going to take that answer and multiply by 8. And I get 6. So in this case, x equals 6. All right, we're going to do the same thing, but here we have a word problem. So we have to read this really carefully. It tells me to solve. A map has a scale ratio of 2 centimeters to 7 miles. How far apart are two cities if they are 19 centimeters apart on the map? So I want to notice that I'm talking about centimeters and miles, and it says a scale ratio. Scale was one of our vocabulary words, and scale just means that they move together or they change together. So if I have 2 centimeters for every 7 miles, then when I look at this and I see 19 centimeters, I want to make sure my centimeters stay up here, and my variable will be miles. I don't know how many miles it is, okay? Now notice my variable here is in the denominator spot, so I have to use the reciprocal. So I'm going to flip it to 7 over 2 and x over 19, and then I have to multiply each side by 19. So over here I would have x, and over here I'm going to figure out 7 divided by 2, and I have 3 5/10, and then I'm going to take 3 5/10 times 19, and that gives me 66.5 miles. So what are we comparing? In this case, we're comparing centimeters to miles. And since it's a scale ratio, we're also going to be comparing centimeters to miles on the other side. All right, here's a really important part for your summary. It says, when do we want to use reciprocals to solve a proportion? Remember, reciprocals are when we flip the numerator and the denominator. We need our variable to be in the numerator spot. So we use reciprocals when it is not.